Hello everyone, welcome to this problem where we are going to dive into number of ways to divide a long corridor. So basically you have a long corridor that consists of seat and plant, and then you have to divide them, and the rule is that when you divide, each slot that has been divided should contain an even number of should contain exactly two seats. That means I can divide here, I have two seats here. I can put a divider here. I can put a divider also here, which is the solution. I can put a divider here, which is the solution. But I cannot put a divider here. Why? Because if I divide here, this guy is going to have three seats, which is actually not respecting the condition that has been defined. Understand? So that being said, the whole problem here is to find how many valid division we can have. Now I'm going to address with you my thinking, my approach of solving this with a couple of examples. Let's say I have this as example. How many possible solutions do I have here? The answer is simply one. Why is that? Because I have only two s here. So the only split possible is a split that will take everything, right? Because if I try to take a part that doesn't contain everything, the other sub part is going to contain something that will be invalid because I only have 2s. Okay, so now if I put another s here, how many solutions do I have? In this scenario, I have zero solution. Why is that I have zero solution? Because it's not possible for me to split here in such a way that each part will contain exactly 2s. Why? Because we have an odd number of s. This already gives us an indication of, hey, the number of s should be actually an even number. So this will help us to handle edge cases. That means, okay, we know that the number of s should be even number. Now if you want to deal with even number, the question is actually 0 part of the solution? That means, because 0 is an even number, but if you have 0s, is that still a solution? And the answer is no, because if I have a solution just like this, yeah, the number of s is actually 0, which is even, but this is not a valid solution. Why? Because we cannot have a split that contains exactly 2s. Okay, that being said, we already know that now our edge cases is that it should be even and it should be greater than 0. This is the edge case that we are going to handle. Now, how do we compute now the number of possible separation? Let's say I have this. If I add another s here, what are the possible solutions? I can divide here. You do agree with me that I can divide here? I can also divide here, which will give me two solutions. There are two possible solutions with this combination because I can divide here and I can divide here. Another interesting thing is that if I have an extra p here, it will not change the number of solutions. I can still only divide here and here. And this kind of gives a direct insight, which is you can only divide between valid solution or valid sub-solution. That means if I have this, which is a valid sub-solution, and I have this, which is a valid sub-solution, then I can find a couple of divisions in between. Make sense? That means if I have maybe s here, the number of p I will have here, each of the p that I will have here can act as a valid division only if I have another valid solution after this. Right? Now that we have this, what we can come up with is that, okay, we are going to count the number of s. If the number of s is actually even, we are going to make it even. If the number of s is actually even, then we can count the number of p after that. And the next s we are going to see, we can now use this to count the number of value separation that we can make between those two elements. And keep in mind that each group of value solution can make solution with the other group. That means if I have maybe 3 possibility here and I have 4 possibility here, at the end I will have this one, this time this one, because each of here can match with each of here. And that is the idea of solving this. Now that you have the idea, you can implement now the solution on your own by thinking of an approach. My approach of solving this will be as follows. I'm looping from the beginning till the end. Whenever I'm seeing a P and I have an odd number of S and an even number of S, I count it. That means when I will see this P, I will do nothing, because it's not a P that can act as a part of division. When I'm going to see this guy, I'll just count the number of S. When I'm going to see this guy, I count the number of S. When I'm going to see this guy, I will compute this one because I previously had an even number of S. That means this guy can act like an element that will be part of a separation. And when I'm seeing this S, I say, okay, this is the first S I'm seeing after a valid solution. So at this point I can compute, and I will compute based on the number of P that I have in between them. If there is just 0 P, that means I will have exactly 1 division. If there is 1 P, I will have 2 division. That means 1 year and 1 year. So you just understand that the number of division you have is just the number of P plus 1, and then just times all the group. So my solution will look like this. I'm going to have an answer which I'll initiate at 1. I'll tell you because I'm doing multiplication, as I just mentioned. I'm doing a group multiplication. You may ask yourself now, if I'm starting at 1, what is the case of 0? The idea is simple, that if I'm starting at 1, I'm computing, and if at the end I realize that the count that I have is actually an invalid solution, I'll return 0. Otherwise, I return what has been stored in my answer. So yeah, I'm saying, okay, if I'm finding a P and the count of S modulo 2 is equal to 0, and the count of S is different from 0, then I count the P. This extra different from 0 will help me to avoid counting starting P, because I will not use them, so I don't want to count them. This count modulo 2 equal to 0 help me to count P data only after valid sub-solution, and then P is just to check that it is a P, so I count the number of P. Now else, if it's a C, if it's an S, now okay, if I have an S, what do? I need to increment the number of S always. Now I need to check. When I will find this S, I will not compute anything. When I will find this S, I will not compute anything. But when I will find this S, I will compute something. Why will I compute something when I will find this S? Because it's actually the beginning of a new solution, which is actually an odd number of S. Okay, so you got the idea overall, that is it. So and then now you compute a solution by saying, okay, you have the ans times the number of P in between modulo what has been set here, and at the end this one will give you the value of the ans if there's a valid answer, and you just check here to make sure that there's a valid answer. If any of these two conditions is respected, that means it's actually an invalid scenario, you return 0. Otherwise, you return the ans. Let us submit and see what it will give. We are running this. Okay, we have a valid solution that is actually performing pretty well. So this is my approach of solving this. I hope you do enjoy it. Feel free to give me any input, feedback. I will be really happy to interact with you regarding this. See you tomorrow. Ciao.